Hello, my dear students. Hope you are all well, and welcome to our class Easy Chemistry. And before going through our today's class, first I will like to request my dear student to please keep your notebook handy and try to write down what I am writing on the whiteboard. Otherwise, you all forget this. And so, without wasting time, let's start. So, today's topic is the second order reaction. And in our previous class, we have learned some simple form of second order reaction, and I am providing the link of that class dealing with the second order reaction. You will find this class from the description box where I have provided the link of the first part 1 class of second order reaction, and today we will going to discuss some complex type second order reaction, and the case is little bit complex. Let the reaction like nu1 a plus nu2 b is the product. Let if this is the case, and let this is a second order reaction. This is this second order reaction, and first order with respect to reactant A and reactant B. So what will be the rate? The rate of the reaction R equals to K into A into B. So look, the reaction is first order with respect to A. So the power of the concentration of A is 1, and the reaction is also first order with respect to the reactant B. So the power of the concentration of the reactant B is 1, and the overall order of the reaction is 1 plus 1 2. So overall order equals to 1 plus 1 2. So it fulfills our assumption which took this is a second order reaction. So this is the whole scenario. K is the rate constant. So what we are going to do, we are going to reduce the rate constant. Okay, and let what is the a0? A0 is the initial concentration of A at time t equals to 0. What is the B0? B0 is the initial concentration of B at time t equals to 0. And A, what is the A? A is the concentration of A at any time t. And what is B? B is the concentration of B at any time t. Okay, and x is the extent of the reaction. Extent of reaction at time t. Okay, so these are the things I must explain before going through the full reduction. So our reaction is like this: nu1 a, nu2 b to p. So where time t equals to 0, the what will be the concentration? The concentration of A is A0, and this is B0, and this is 0. And at the time t, the concentration of A is A0 minus nu1x, and this should be b0 minus nu1, sorry, nu2 x, and this is x. So this is the scenario. So what happened? So what we get, a is the concentration, of reactant A at time t. So concentration of A is nothing but concentration of A0 minus nu1 x, and concentration of B is nothing but concentration of B0 minus nu2 x. So this is the equation 1, you can say. This is equation 2, equation 3. Okay, so my dear students, please write down the notes. So what happened? Now the differential rate law. What will be the differential rate law? The differential rate law so the differential rate law gives 1 by nu 1 with respect to A. We are going to deal with the respect to A only. So 1 by nu 1 dA equals to 1 by nu 2 dB t equals to dP by t. This is our differential rate law. So this is equation 4, and this is the rate. So comparing equation 1 and 4, so I am writing here all the equation. What was our equation 1? Our equation 1 was reaction. This is the rate constant, A into B, and this is our equation 1. And what is our equation 2? Equation 2 is A into A0 mu 1 x. What was our equation 3? This is B0 mu 2 x, and all these are equations we sum up at the right hand corner, right hand side of the whiteboard. So comparing equation 1 and 4, we have minus 1 by nu 1 dA dt equals to k into A into B. Now substitution the values of A and B from equation 2 and 3. So substituting the values, substituting A and B from equation 2 and 3, where this is equation 5 at equation 5. So what we get, mu 1 dA by dt. So here again, in place of A, we get the substitution. In place of A, we get, and here again in place of A, and here due to x. So now simply the side change. Now what we get, so the first term, the a0 is constant, so its time derivative will be 0. First term will be 0. The next term, first the sign minus minus plus, and 1 by nu 1, and here the nu 1 is constant, So it comes out of the derivative, so it gives only dx dt equals to k into nu 1x, and here we sum up our reaction. R equals to minus dt, and our fifth equation will be, after competition, so here again we get dx dt equals to k, actually this cancel, and it gives, now taking the sides, we have dx here divided by k dt. Okay, so this is our sixth equation. Now we are going to integrate this equation. Equation 6 is our guiding equation here. No, so we are going to integrate the equation 6. Okay. So my dear student, I again requesting you to please write down the notes what I have written on the whiteboard. Please write down the note by pausing the video. Now I am going to remove this because the shortage of space in my whiteboard. So what was our last equation? If you remember, our last equation will be like this: dx nu 1x, and here b0 nu 2x, and here k dt. So this is our equation. So what we am doing, just taking out the common of nu 1 b0 minus nu 2 a0. So if you take it, can the separation of variable, the equation we am doing, we are doing nothing but the separation of variable dx k dt. If you carry out the calculations, you will get this. Okay, so now integrate x varies from 0 to x, mu 1 dx, here mu 1x minus, here also it dt. Okay, and t runs from 0 to t. This is the lower limit of 0 of time, and this is the upper limit of time. This is the lower limit of extent of reaction 0 at the time when time t equals to 0. No reaction, mm, no reaction has been occurred. So the extent of reaction is 0 at the time t equals to 0, and this is x, the extent of reaction x at the time t equals to t. So what it gives? This gives log natural. This gives the log natural. Uh, what gives this? The whole thing after putting the form gives log natural nu to x by a0 x nu minus, there should be minus, or in terms of plus, log natural b0 by a0. So after integrating this, you will get the final formula of, so we have to be minus, so k dt, so it gives only kt. Okay, my dear students, so this is the formula, and you can also simplify this formula. Nu1 b0 minus nu2 a0, so this is the full formula of log a minus log b. Log a minus log b means log a by b, so it gives a0 into b0 nu to x, and here b0 so kt. So what will be our k? So k equals to 1 by t into nu1 b0 nu2 a0 into, if you multiply 2.303, if you multiply 2.303, so it gives, what gives it? It gives 2.303 log this a0 b0 minus 2x so this is our final form. This is our final form. This is our k. And so, my dear students, I hope you can learn something out of this class. And although this is a very complex scenario, but it is not uh, very common for your board exam. But if you are preparing for any entrance exam, then such kind of reaction may have been asked. So my dear students, if you think the class is noteworthy for you, please subscribe my channel, and I'll bring you some more important classes in the future days. So till then, goodbye, have a nice journey.